Hello everyone, hope you're doing fine. Welcome back to another video from my channel. In our previous video, we discussed about displacement time graphs, velocity time graphs, acceleration time graphs, SUVAT equations or the kinematics equations under constant acceleration, and finally the vertical motion of a projectile or simply its free fall under gravity. Today, however, we will be discussing about 2D vectors that are involved in Mechanics 1. And as mentioned before, a vector is a quantity which has both magnitude and direction. These are some examples of vector quantities, such as displacement, which is the distance in a particular direction, whose unit is meters or m. Velocity is the rate of change of displacement, or in a displacement versus time graph, it is the gradient of the graph, whose unit is meters per second. Similarly, we have acceleration, which is the rate of change of velocity, or the gradient of the velocity versus time graph, whose unit is meters per second or meter per second squared. We have force or weight, described by magnitude, direction, and point of application, whose unit is Newton. A scalar quantity has magnitude only. These are some examples of scalar quantities. For example, distance, which is a measure of length, similarly with a unit of meters. Speed, which is a measure of how quickly a body moves, which is in meters per second. Time, which is a measure of ongoing events taking place, which is in seconds. And finally, mass, which is a measure of the quantity of a matter contained within an object, whose unit is kilograms. Scalar quantities are always positive. When considering motion in a straight line, vector quantities can be positive or negative as discussed previously. Let's look at an example. A girl walks 2 km due east from a fixed point O to A, and then 3 km due south from A to B. Find the total distance walked and describe the displacement of B from O. The total distance will be 2 plus 3, as it is the total distance traveled regardless of the direction. So the distance is 5 kilometers. And to describe the displacement, we have to consider the diagram, which is something like this, where the girl walks 2 kilometers to the right or the east, and she also walks 3 kilometers due south. So because this angle is 90, so we can use Pythagoras to calculate the distance OB, and hence the displacement of the girl from O to B, which is represented by this line. So using Pythagoras, we have OB square equals to OA square plus AB square. So OB is equals to 3.61 kilometers, which is in 3 significant figures. And considering the angle or the bearing, we can say that using tan AOB, which is 3 by 2, using this as theta, so we have 56.3. Now, to get the bearing from north, we have to say that this is our bearing. So to calculate the bearing, we have 90 plus theta. So we have 90 plus 56.3, which is 146 degrees. And a very important point to remember is that bearing is always measured clockwise from north. So when a vector is written in terms of the unit vectors I and j, you can find the magnitude using Pythagoras theorem. The magnitude of vector A is written as modulus of A, and you can describe vectors using I and j notation, where I is the horizontal unit vector on the x-axis and j is the perpendicular unit vector placed on the y-axis. And unit vectors always will have a magnitude of 1. You can also write any two-dimensional vector in the form of AI plus BJ. So in this triangle, we can say that by using the triangle law of addition, for vectors we have AC is equals to AB plus BC. So therefore we have 5i plus 2j as the AC. Similarly, we can also use the parallelogram rule. For example, if we have two vectors A and B, then the resultant of the two vectors will be the diagonal of the parallelogram displayed as r here. The velocity of a particle is a vector in the direction of motion. Its magnitude is the speed of the particle, and the velocity is usually denoted by v. If a particle is moving with constant velocity v meter per second, then after t seconds it will have moved vt. The displacement is parallel to the velocity. The magnitude of the displacement is the distance from the starting points. From our last video, we established that velocity is equals to displacement divided by time taken. So therefore, if the velocity is constant, we can say that s, or the displacement, is equals to the velocity multiplied with time. So now let's do an example question which says to find the speed and the distance traveled by the particle moving with a velocity being minus 3i plus 4j for 15 seconds. Therefore, we know that the speed is the modulus of v, or the magnitude, and using Pythagoras' theorem, we can say that the modulus is equals to root over 3 square plus 4 square, which should be 9 plus 16, which is also root over 25. And because we know that 5 square is also 25, therefore root over 25 is simply 5 meter per second. And also we have to calculate the distance traveled by the particle in those 15 seconds. Therefore we can say that distance is equals to speed into time, so 5 into 15, which is 75 meters. For number B, v is given as 2i plus 5j, and so similarly the speed will be the modulus of velocity, so root over 2 square plus 5 square is equals to root over 29, or approximately equals to 5.39 meter per second. And we know that displacement or distance is equals to velocity into time, so therefore we have root over 29 into time, which is 3 seconds, so 3 is equals to approximately 16.2 meters. For number C, we have velocity equals to 5i minus 2j kilometer per hour. So we have to be cautious of the units given. So therefore speed is equals to the modulus of velocity as discussed previously. So we have root over 5 square plus 2 square, and we have similarly 25 plus 4, which is root over 29, which is approximately equals to 5.39 kilometers per hour. Similarly, distance is equals to velocity into time, so v into t, we have 53.9 multiplied with 3 hours, which is equals to 16.2 kilometers. And finally, for number D, we have velocity is equals to 12i minus 5j. Therefore, speed, or the modulus of velocity, is equals to 12 square plus 5 square, which is also 13 square, or 13 kilometer per hour. And so our distance becomes 13 into 30 minutes, but because we have the units as being per hours, that's why we need to convert minutes into hours. As we know that 60 minutes is equals to 1 hour, therefore we can say that 30 minutes should be half hour, or 0.5 hours, because 30 is half of 60. So we can write that being 30 by 60, and our final answer is 6.5 kilometers. And the acceleration of a particle tells you how quickly the velocity changes with time. Acceleration is a vector usually denoted by A or bold A, and if a particle with initial velocity u moves with a constant acceleration a, then its velocity v at time t is given by v is equals to u plus at, which is exactly same as we discussed in our previous video in our SUVAT equations. A force applied to a particle has both magnitude and direction, so force is also a vector quantity. The force causes the particle to accelerate, where we have F is equals to ma, where m is the mass of the particle. And this is Newton's second law, which states that force, or the resultant force actually, is proportional to the acceleration of the object, or can be written as F is equals to dp by dt, or rate of change in momentum with respect to time. And finally, one of our very important formulas, if a particle starts from the point with position vector r0 and moves with constant velocity v, then its displacement from its initial position at time t is vt, as discussed here, and its position vector r is given by r is equals to r0 plus vt. A very important concept to remember for the vectors is that if we have two vectors that are parallel to each other, for example, if we have A is parallel to B, so we write that being A parallel to B, therefore we can say that A is equals to lambda B, where lambda is a constant and a scalar value. And here A and B are both vectors. And similarly, if we have two vectors that are parallel to each other but in the opposite direction, so we can say that A is equals to lambda B, and here the value of lambda should be negative, so we can denote that as being lambda is less than 0, meaning that the direction of A and B are in opposite direction or reversed. So now let's move on to some exercises. For number 1, we have at 8 a.m. two ships A and B are at RA, which is the position vector of A being I plus 3j kilometers. RB is equals to 5I minus 2j kilometers from a fixed point P. The velocities are VA is equals to 2I minus j kilometer per hour, and VB is equals to minus I plus 4j kilometer per hour respectively. Write down the position vectors of A and B t hours later. So here we have to use the formula r is equals to r0 plus vt, because the velocities are constant, and for A we can say that OA, or the position vector of A with respect to O, is r0, which is I plus 3j kilometers, plus velocity into t, which is 2I minus j whole multiplied with t, is equals to, combining the I and j components, we have 2t plus 1 whole multiplied with I plus 3 minus tj. And for OB, or the position vector of B with respect to O, we can say that the R0 of B is 5I minus 2j, so 5I minus 2j plus the constant velocity, which is minus I plus 4j multiplied with t, and so simplifying we have 5 minus t I plus 4t minus 2j, and this is our answer. For number B, we have to show that t hours after 8 am the position vector of B relative to A is given by this. So that means we have to find out the vector AB. So if we have two vectors OA and OB, for example OA being here and this being denoted as A, similarly if we had a vector OB which is denoted by B, Therefore, AB can be written as AO plus OB. And so here we have AO plus OB. So because we have the expression for OA, therefore AO means that the direction of the vector is reversed. So we have minus 2t minus 1 I minus 3 minus tj and plus OB, which we had found out before as being 5 minus ti plus 4t minus 2j. And so simplifying and combining the I components and j components, we can say that 5 minus t minus 2t minus 1 I plus 4t minus 2 minus 3 plus tj, and further simplifying we have 5 minus 1, which is 4, so 4 minus 3t, 4t plus t is equals to 5t, so we can write that being 5t, and minus 2 minus 3 is minus 5, therefore our answer is 5t minus 5j. So for number C, we have to show that the two shapes do not collide. So in number C, if A and B do not collide, therefore A and B should not be equals to the 0 vector or 0i plus 0z. So therefore, if we say that 4 minus 3t plus 5t minus 5 is equals to 0i plus 0z, and equating the I components, we can say that 4 minus 3t is equals to 0. So our answer of t should be 4 by 3. And if we equate the j components, we should get 5t minus 5 is equals to 0. So therefore, t should be equals to 5 by 5, which is also 1. Now because we have two values of t which are not consistent with each other, therefore we can say that A and B do not collide because their combined vector AD is never equals to 0. For number D, we have to find the distance between A and B at 10 a.m. So for number D, to find out the distance, we have to say at time is equals to 10 a.m. We have to find out the value of t here. Now because the two shapes initially started at 8 a.m. therefore we can say that at time is equals to 10 a.m. t must be equals to 10 minus 8, which is 2 hours. Therefore we can find the expression for AB being AB is equals to 4 minus 3 into 2 I plus 5 into 2 minus 5 j, and so our expression for AB becomes minus 2i plus 5j. And so as we know, the distance is the modulus of the displacement vector. Therefore we can say that the modulus of AB vector is equals to root over 2 square plus 5 square, and is equals to root over 29, which is also approximately equals to 5.39 kilometers. And for number 2, which is number 5 from chapter review 3 from the book, we have two boats A and B moving with constant velocities. Boat A moves with velocity 6i and boat B with velocity 3i plus 5j. And for number A, we have to find out the bearing on which B is moving. So for 2A, because we know that the bearing is always measured from the north clockwise, so therefore for this case we can say the bearing should be this angle theta. So if we use a right angle triangle like this, we can say that this side is 5 and this is 3. So if we consider this being theta, therefore we can use tan theta is equals to 3 by 5, and so therefore using the calculator of tan inverse 3 by 5 or arctan 3 by 5, we are supposed to get 30.96 degrees, or in bearing form it is approximately equals to 0.31 degrees. At noon, A is at point O and B is 10 kilometers due south of O. At time t hours after noon, the position vectors of A and B relative to O are A kilometers and B kilometers respectively. So we have to find out the expressions for A and B in terms of E. So here we have to use the formula R is equals to R naught plus BT. So for A we can say RA, or OA is equals to R naught, and here R naught is 0 because at noon A is at point O, so therefore 0 is the position vector for the origin here, plus BT, which is velocity, 6I into T. And so our expression of OA is 6TI. For RB, or the position vector of B after time t, is equals to OB, which is R naught, and here the R naught can be found out using this information, which is said that B is 10 kilometers due south of O. So if you draw the positions for north, south, east and west, we had north here, south here, east here and west being here. So because B is 10 kilometers due south of O, so therefore B must be in this position and this must be 10. So therefore the R naught for B is minus 10J, because the y-axis is considered as J. So this being the negative y-axis, we have this being minus 10J plus V into T, and here V is 3I plus 5J whole multiplied with T. And so combining I and J components together, we have 3T I plus 5T minus 10J. And so RA is the vector bold A and RB is the vector of B. So for number C, we have to find the time when A is due east of B. And if you remember previously, we know that north is here, east is on the right, west is on the left, and south is at the bottom. So we can say that as A is due east of B, therefore, if we plotted both of the positions of the shapes, we would have B here and A here, meaning that A is due east of B. So therefore, we can say that the J components of the vector AB should be 0, because here we can see that there is only an I component but no J component. Therefore, we can say that if A is due east of B, so therefore the Z component of AB, here it is 5T minus 10J, must be equals to 0J. So equating both sides, we have 5T minus 10 equals to 0, and so T is equals to 10 by 5 or 2 hours. So the time should be 12 plus 2, As we know that initially both of the shifts started at noon, and we know that noon means 12 p.m. So therefore time should be 12 plus 2, which is 14:00, or can be written as 2 p.m. So for number D, is given that at time t hours after noon, the distance between A and B is d kilometers. So by finding an expression for AB, show that b square is equals to 34t square minus 100t plus 100. So because we know that AB is a vector, therefore the distance between A and B should be represented by the modulus of AB vector. So first we have to find the vector AB, and as we know, AB can be written as AO plus OB, and just for reference, if this is OA and if this is OB, so therefore AB, which is this line, should be AO to OB. So we know that OA is 6ti and OB is 3i plus 5t minus 10j. So therefore AO must be OA reversed. So it should be minus 6ti plus OB, which is 3ti plus 5t minus 10j. And so minus 6ti plus 3ti is minus 3ti, and finally the answer is minus 3ti plus 5t minus 10 whole multiplied with j. Now we can find out the modulus of AB, or the distance d. So we can write that being modulus of AB is the square root of 3t whole squared plus 5t minus 10 whole squared, and using a minus b whole square formula, we can say that it is a squared minus 2ab plus b squared, and so we should get 9t squared plus 25t squared minus 2 into 5 into 10, which is 10 here, and multiplied with 10 is another 100, so minus 100t plus 10 squared, which is also 100. And so our final answer is 34t squared minus 100t plus 100. And because we know that the modulus of AB is equals to D, therefore we can get our required expression for D squared by squaring both sides, and we should get 34t squared minus 100t plus 100, and this is our required answer. And in number E, we have to find out the time after noon at which the boats are again 10 kilometers apart. So that means we have to say that our value of D must be equals to 10. So therefore D square must be 100. So we can say 34t square minus 100t plus 100 is equals to 10 squared, or 100, and 34t square minus 100t plus 100 is equals to 100. So because we have hundreds on both sides, we can cancel each other out, and so taking a common factor of t here, we can say that t multiplied with 34t minus 100 is equals to 0. So we can say either t is equals to 0 or 34t minus 100 is equals to 0, and rearranging for t, we have t is equals to 100 by 34, which is approximately 2.94 hours. And so we have to find out the time which should be 12 plus 2.94 hours, which also can be written as 14 hours, and we have plus 0.94 hours, because we know that 1 hour is equals to 60 minutes. Therefore 0.94 hours should be 60 multiplied with 0.94, which is also equals to approximately 56 minutes. So we have 14 plus 56 minutes, and so our actual time is 14:56, or in a 12-hour format it should be 2:56 p.m. and this is our answer. For number 3, which is an official question from Jan 2020, question number 6, and is given that F is a force which is 10I plus J Newton. So we have to find out the magnitude of F in its exact value. So we know that the magnitude of the force should be the modulus of the vector. So modulus of F is equals to root over 10 squared plus 1 squared. So this is 100 and this is 1. Therefore our exact value is 101 newtons. For number B, we have to find out the size of the angle between the direction of F and the direction of the vector I plus J. So there are mainly two ways of doing this. The first method, which is the easier one, is to plot and visualize the graph. And if you have I here and if you have J here, then I, J, which should be 1 and 1 should be here. So this should be I plus J. And for the force F, we can say that if this is 10, so this should be our required point and F should be here. So to find out the angle between F and the direction of I plus J, we have to calculate this angle, which is theta. So we can calculate this angle first, known as alpha 1, and we can also calculate this whole angle, which is alpha 2. So we have two right angle triangles, one being like this and another being something like this. So here we can say that this length is 10 and this is 1, as this is 1, and here this is 1 and this is 1. So this should be alpha 2 and this should be alpha 1. So for both cases we can use tan alpha 2 is equals to 1 by 1, which is opposite by adjacent. We know that 45 is an angle where tan is 1. So alpha 2 is equals to tan inverse of 1, which is 45 degrees. And similarly here we can use tan alpha 1 is equals to 1 by 10. So therefore alpha 1 is equals to tan inverse of 1 by 10, which is approximately equals to 5.71 degrees. And so our required angle theta, which is the difference between the two angles, is 45 minus 5.71 degrees, which is also equals to 39.3. And another alternative way of doing number B is by using the cosine rule. If you consider the triangle itself, which is something like this, and here we know that this is root over 101, which is this one, as this is F, and we can find out the modulus of I plus J vector, which is 1 square plus 1 square, which is root over 2, the modulus of I plus J, So this should be root 2, and because we know that this point is 1, so therefore we can say that this whole length or this length is 10 minus 1, which is 9, so this should be 9. So because this is theta, we can say that in a triangle ABC, if this is theta and if this is A, B and C, then we know the formula for the cosine rule, where cos theta is equals to B square plus C square minus A square and whole divided by 2 multiplied with BC. And using the same formula, we can say that cos theta is equals to B square, which is root over 101 squared plus root over 2 squared minus 9 squared divided by 2 into root 101 into root 2. And so theta should be cos inverse of this, which is approximately 0.773957 and so on. So the value is 39.3 degrees, which is the same as previously. For number C, the resultant of the force F and the force minus 15I plus AJ, where A is a constant, is parallel to but in the opposite direction to the vector 2I minus 3j. So therefore, as I mentioned previously, if we had two vectors A and B which were parallel to each other, so we can say that A is equals to lambda B or A is equals to mu B, where mu and lambda are constants and scalar values. So we can say that the resultant, which is the addition of all forces, is equals to F plus that vector, which is minus 15I plus AZ. So therefore we can say that R is parallel to the minus of 2I minus 3Z. Therefore we can say that minus 5I plus A plus 1 whole multiplied with J is equals to minus lambda of 2I minus 3Z. And so simplifying the right hand side a bit, we have equals to minus 2 lambda I plus 3 lambda Z. So equating the I components, we can get that minus 5 is equals to minus 2 lambda. So lambda is equals to 5 by 2. On the right hand side, we can say that A plus 1 is equals to 3 lambda. So therefore A is equals to 3 lambda minus 1. And so because lambda is 5 by 2, we say 3 into 5 by 2 minus 1, which is 15 by 2 minus 1, or 13 by 2, which is equals to 6.5. And this is our answer. So let's now move on to number 4, which is an official question from May 2020. So this is the question number 5 from that paper. We're given that v, or the velocity vector, is equals to 7 minus 5t I plus 12t minus 20 whole multiplied with j. When t is equals to 2, velocity v is equals to 7 minus 5 into 2 I plus 12 into 2 minus 20 j. So 7 minus 10 is minus 3 I plus 4j, as 12 into 2 is 24. So 24 minus 20 is plus 4, and this is our velocity expression. Now we know that speed is the modulus or the absolute magnitude of v. So we get root over 3 squared plus 4 squared, which is root over 25. And because 5 squared is 25, so we can say the speed is 5 meter per second. For number B, we have to find out the size of the angle between the direction of motion of p, which is the velocity, and the vector j when t is equals to 2. So plotting this velocity and the vector j on a graph, you can see that if this is minus 3, we know that this is I, so this is minus 3I, and this is 4j. So this is our required vector, and this is 4j. Because this y-axis is j, so we have to find out this angle, which is theta. So if you draw a perpendicular and construct a right angle triangle, so we should have this side being 4 and this side being 3. And so if this is theta, we can say that tan theta is equals to opposite, which is 3, by adjacent, which is 4. So theta is equals to tan inverse of 3 by 4, which is 37 degrees. Now for number C, the constant acceleration is a. So there are mainly two ways of doing it. First of all, we can consider the calculus behind acceleration, and we know that acceleration is the gradient of the velocity time graph. So therefore we can say that in our calculus notation it should be dv by dt. So we can differentiate the velocity vector with respect to t. So applying the dt of 7 minus 5 t I plus ddt of 12t minus 20j. So using the power rule, we know that the differentiation of any constant is 0, and here it should be 0 minus 5 I, and the dt of 12t is simply 12j, because the differentiation or the derivative of any constant such as minus 20 is also 0. So this is our answer. And another alternative way of finding the acceleration is using the value of the velocity that you found previously, which was at t is equals to 2. We know that the final velocity is minus 3I plus 4j, as we got in number A. So now we find out the velocity at t is equals to 0, or its initial velocity u is equals to 7 minus 0, as 5 into 0 is 0, multiplied with I plus 12 into 0 minus 20 j. So our initial velocity is 7I minus 20j. So we know that acceleration is equals to change in velocity divided by time, or v minus u whole divided by t. So plugging in those values, we have minus 3I plus 4j minus minus 7I minus 20j, and whole divided by 2. And so simplifying, we have minus 3 with minus 7, which is minus 10I, and we have 4 plus, because minus multiplied with minus 1 is plus, so 4 plus 20 is 24j, and whole divided by 2. So our final answer is minus 5I plus 12j, and this is our answer that matched with the previous one. So for number D, we have to find out the value of t when p is moving in the direction of the vector minus 5i plus 8j. So when p is moving in the direction of the vector minus 5i plus 8j, we can say that the velocity vector v is parallel to minus 5i plus 8j, because as I said previously, if, for example, if vector A is parallel or moving in the same direction as vector B, then we can express the two vectors being A is equals to lambda of B, where lambda is a constant, and so we can say that the velocity v, which is 7 minus 5t all multiplied with I plus 12t minus 20j is mu, which is a constant, minus 5i plus 8j. You can also replace this mu using the symbol lambda, because this symbol mu can also be lambda or x or y, because this mu or constant can also be denoted by lambda or x or y or any symbol in particular, unless, so here we use mu because it's a constant, and you can and you could have also used the word, and you could have also used the letter lambda here. So we can say that 7 minus 5t plus 12t minus 20 whole multiplied with j is equals to minus 5 mu I plus 8 mu j. So therefore, equating the I components, we can say that 7 minus 5t is equals to minus 5 mu, and so we can make mu the subject to get 7 minus 5t whole divided by minus 5, and equating the j components, we have 12t minus 20 equals to 8 mu. So similarly, mu is equals to 12t minus 20 whole divided by 8, and so equating both sides, we get 12t minus 20 divided by 8 is also equals to 7 minus 5 divided by minus 5. And so cross multiplying, we should get minus 60t plus 100 is equals to 56 minus 40t. So therefore we can say that 100 minus 56 is equals to 60t minus 40t. And so t is equals to 44 divided by 20, or can be written as 2.2 seconds, and this is our answer. For the last math, number 5, which is a question from Jan 2021 from number 6, it said that two girls, Agatha and Bryony, are roller skating inside a large empty building. The girls are modeled as particles. At time t is equals to 0, Agatha is at the point with position vector 11i plus 11z, and Bryony is at the point with position vector 7i plus 16j meters. The position vectors given are relative to the door O, or the origin, and I and j are horizontal perpendicular unit vectors. Given that Agatha skates with constant velocity 3i minus j and Bryony with velocity 4i minus 2j. So for number A, we have to find out the position vector of Agatha at time t. So here we have to use the formula r is equals to r naught plus vt. So for Agatha, we can say that OA, or the position vector of Agatha, is equals to r naught, which is 11i plus 11j, plus v into t, which is 3i minus j, whole multiplied with t. And so our final answer is 3t plus 11 whole multiplied with I. So here we have I, and plus 11 minus t whole multiplied with j. So for number B, it's given that at t is equals to 6 seconds, Agatha passes through the point P. Show that Bryony also passes through point P and find the value of t when this occurs. So first we have to find the point P, which is when t is equals to 6, the position vector OA becomes 3 multiplied with 6 plus 11i plus 11 minus 6 whole multiplied with j, and 3 into 6 is 18 plus 11 is 29, so this is 29i, and 11 minus 6 is simply 5, therefore we have 5j here, and this is a position vector of P. Now similarly, like we did with number A, we have to find out the position vector of Bryony or OB. So using the same formula, r is equals to r naught plus vt, we can say that OB is equals to r naught, which is 7i plus 16j for Bryony. So 7i plus 16j plus t into the velocity, which is 4i minus 2j whole multiplied with t. And so combining the I and j components together, we can find 7 plus 4t multiplied with I plus 16 minus 2t multiplied with j, which is the j component. And so if Bryony passes through the point P, therefore this whole vector should be equals to 29i plus 5j. So equating OB is equals to 29i plus 5j, we have 7 plus 40 I plus 16 minus 2t j is equals to 29i plus 5j. So therefore, if we equate the I components, we have 7 plus 40 is equals to 29, and so t is equals to 29 minus 7 whole divided by 4. We know that 29 minus 7 is 22. So our answer is t is equals to 11 by 2 seconds. So comparing the j components, we have 16 minus 2t is equals to 5. Therefore t is equals to 5 minus 16 whole divided by minus 2. And we know that 5 minus 16 is minus 11, and divided by minus 2 is also 11 by 2 seconds. So because both of the time values are consistent with each other, therefore we can say that B passes through P, and the time value is 11 by 2 seconds. For number C, we have to show that AB is equals to this. So we know that OA is equals to 3t plus 11I plus 11 minus t j and OB is equals to 7 plus 40 whole multiplied with I plus 16 minus 2t j, which we obtained from the previous questions from here. And so we have to find the vector AB. We know that AB vector can be written as the addition vector using the triangle, which is AO plus OB. And AO is minus 3t minus 11I, because AO is reversed, plus minus 11 plus t j plus OB, which is 7 plus 4t I plus 16 minus 2t j. So adding the components together, we have minus 3t plus 4t, which is t, and minus 11 plus 7, which is minus 4, and this is the I component. For j, we have t minus 2t, so minus t here, and minus 11 plus 16, which is 5, so 5 minus t whole multiplied with the j vector. So therefore this is our answer, and the units are in meters. So for number D, we have to find the distance between the two girls when they are the closest together. Now we know that AB is the position vector of B with respect to A. Therefore the modulus of AB should represent the distance between the two people. Therefore we can say that the modulus of AB should be equals to root of t minus 4 whole square plus 5 minus t whole square and squaring both sides we have modulus of ab squared. So we know the formula of a minus b whole square being equals to a squared minus 2 into ab plus b squared So therefore, using that formula, we can say that t minus 4 whole square is t squared minus 2 into t multiplied with 4 plus 4 squared plus 5 minus t whole square, which is also 5 square minus 2 into 5 into t plus t squared. And so simplifying, we get t squared minus 2 into 4, which is 8, t plus 4 square, which is 16, 5 square, which is 25, minus 2 into 5, which is 10, so minus 10 here, and finally plus t squared. So further simplifying, we get 2t squared minus 18t plus 41. So now we have to find out the minimum value of this quadratic equation. So in order to do that, we need to complete the squares, meaning, so we have to express the quadratic in the form of a into x plus b whole square plus c. And so in order to do that, first of all, we need to take a common factor of 2. So we have t squared minus 9t plus 41 by 2. So now we have to compare this part with a minus b whole squared, which was mentioned before, being a squared minus 2ab plus b squared. So we can say that this can be rewritten as t squared minus 2 multiplied with t, and because this is 9, so in order to keep 9 the same, we have to multiply with 9 by 2, so that if you multiply all of these terms together, you get 9 again, and then plus b squared. Here the value of b is 9 by 2, so we have to place plus 9 by 2 whole squared here. And because we took 9 by 2 whole square, therefore we also have to subtract the expression with 9 by 2 whole square again, so that the resultant of these two values is 0 plus 41 by 2. And so further simplifying, we can now express this whole thing as a complete square, for example a minus b whole square. So we should have t minus 9 by 2 whole square, because as mentioned previously, the value of b here is 9 by 2, and minus 81 by 4 plus 41 by 2. Performing the fractions, we know that minus 81 by 4 plus 41 by 2 is equals to minus 81 plus 2 into 41, because the denominator is 2 and we have to make it to 4, therefore we need to multiply both numerator and denominator with 2, so we should get 82 here and divide by 4, which is 1 by 4. So this thing becomes 1 by 4, and so the answer is 2 whole multiplied with t minus 9 by 2 whole squared plus 1 by 4 or 1/4, and so multiplying both sides with 2 we get 2 into t minus 9 by 2 whole squared plus half, and so the minimum value of d square is half, because we know that the value of any square, for example x square, is always greater than or equals to 0. So we can say that t minus 9 by 2 whole square will always be greater than or equals to 0. So therefore, if we multiply it with 2, the inequality should remain same, and adding both sides with half, we should get t minus 9 by 2 whole square is greater than or equals to half, meaning that d square will always be greater than or equals to half. So we can say that the minimum value of d square should be half. So the minimum value of the distance d should be square root of 1 by 2, which is 1 over root 2, or in 3 significant figures we have 0.707 meters. So this brings us to the end of the video. Thanks a lot for watching this video. Please give a like, share and subscribe if you like the content. Goodbye.